Okay, so the first thing that you probably should do is start off and write the equation so you can figure out what happens. So pyridine is C5H5N, and when you put that with water, what happens is the water acts as the acid and it's going to donate its hydrogen. When you have a compound with a nitrogen on the end like this, a lot of times it acts like a weak base. And so it's going to accept that hydrogen, and so you're going to get C5H5NH plus hydroxide. That'll be negative. This should be a positive. All right? All right, so now, since this is the base, and it gives us the Kb value here, we can end up setting up an ice table here. And so what we'll do is we'll set up our ice table. And so to end up getting the pH, we're first going to have to get the pOH, and to get the pOH, we're going to have to know what this concentration is of OH at equilibrium. So at the beginning, we have 0.010 molar of the pyridine. All right. Now it's a weak base, so we know that all of this does not turn into hydroxide. So initially we have that. It's going to change. Then at equilibrium we'll have so much of everything here. So we'll make the ice table. The water doesn't matter. Okay, so this is going to go down, but we don't know by how much. So what we'll just do is we'll just put in 0.010, and it's going to go down by an amount of x. Oops, I did this wrong. It's going to go down by x, so we're going to go minus x. So at equilibrium, we're going to have 0.010 minus x. That's how much of the C5H5N we'll have. Now, we're starting off with 0 amounts of these two. Okay? Now, I probably should put the double arrows here, but since we're at equilibrium, if this goes down by x, it's a 1-to-1 mole ratio. This has to go up by x, and since this is a 1-to-1 also, this will also go up by x. So at equilibrium, we'll have x amount of this and x amount of that. Our goal is to figure out the x of hydroxide, because if we know that, we can use our pH formulas to end up solving for the pH. So what we're going to do is we're going to write the expression. So we have Kb, that's going to equal C5H5NH to the first power, since there's a 1 here, times hydroxide. It will also be to the first power. We're going to divide that by what our reactant is, which is C5H5N. Alright, and it will also be to the first power. Now we'll plug in the numbers. So Kb equals, okay, so this will be x here for this C5H5NH times x for the hydroxide. Divide that by 0.010 minus x. Now what I should have done is not written Kb here, because we know the Kb value here. I should have written that down there. So that will be equal to 1.7 e to the minus 9. Now we can simplify a little bit here. Now you need to listen to this part. Since this Kb is such a small value, we can just disregard this x right here. We can just forget about that. That makes the math a lot easier. And we can combine the stuff that we have on the other side, and so we will get 1.7 e to the minus 9 is equal to x squared over 0.010. And if we solve for that, we end up getting that x equals 4.1 e, 4.1 e to the minus 6. That's supposed to be 4.1 there. All right, that's what x is equal to. Now, x, we know, is our hydroxide. And if we know our hydroxide, we can use our pH formulas, because we know that if we have the pOH, that's equal to the negative log of the OH. And so all we have to do is to find the pOH is to substitute in what we found, which was 4.1 e to the minus 6, so negative log of 4.1 e to the minus 6, and that's going to give us that our pOH equals 5.38. But it doesn't want the pOH, it wants the pH. So now we know that the pH plus POH, that equals 14. So all we have to do to find the pH is just say, well, the pH is going to equal 14 minus our POH, which was 5.38. So the pH happens to equal 8.6. And that's how you would solve that problem right there. Make an ice table, write the expression, plug them in. A big clue is when they give you the KB or the KA and they give you a concentration, you're going to have to make an ice table and use the equilibrium expression to figure out what the pH or the POH is. That's it.